Most of us, just hiking to an altitude above 10 or 13,000 feet results in dizziness, shortness of breath, and the feeling like we're trying to breathe through a straw. These are symptoms of altitude sickness, which happens when there isn't enough oxygen in the air. Or rather, the air pressure is too low for oxygen to get into the blood properly. But for people living in La Rinconada or on the Tibetan Plateau, this is everyday life. And what's most interesting, their bodies have learned to cope with it. Scientists have found that populations living at high altitudes for thousands of years, like Tibetans, Andean people, or Ethiopians from the Semien Mountains, have developed unique biological adaptations that allow them to function where most of us wouldn't survive even a week. How does it work? They have a higher concentration of hemoglobin, which is the protein that carries oxygen in the blood. This means every breath gives their body more oxygen. A faster breathing and heart rate. Their heart beats faster, and lungs work harder to make up for the lack of oxygen. Wider blood vessels. These help spread oxygen better to tissues, especially to the brain and muscles. Altered genes responsible for oxygen metabolism. For example, in Tibetans, a mutation in the EPAS1 gene has been found, which allows them to keep hemoglobin levels low, avoiding thick blood, which surprisingly gives them an advantage over people in the Andes, where too much hemoglobin can be a health problem. This is fascinating because it shows evolution in real time. Humans not only survived in extreme conditions, but learned to live in harmony with them, without technology, oxygen tanks, or medical help. Children are born there, where others would need an oxygen mask, and older people spend their entire lives working physically at altitudes that are the limit for most climbers. This shows that the human body is more than just a biological machine. It's a miracle of evolution that can adapt even to living in a place where there's half as much air as at sea level.